What's it like that?
All right, so it's implicit differentiation. All right, so this is a new topic, but it's not terribly hard. It's just a little weird. All right, so basically it says sometimes we have equations that cannot be solved for one variable. Okay, so an equation kind of like this is an equation of a circle. So if I had x squared plus y squared equals 25, okay, that's not a function. It's a circle that's centered at 0, 0, right, and has radius of 5. Okay, and it's not a function because it doesn't pass the vertical line test. So if I actually wanted to solve for y, and you guys have probably done this as you're trying to put it into your calculator, if you're trying to solve for y, you end up subtracting your x squared over and taking the square root and writing plus or minus. So you end up getting y equals the square root of 25 minus x squared, which is really the top part of your circle. So just right here. And then you get the other one, which is y equals negative the square root of 25 minus x squared, which is another function, which is representing the bottom part of the circle. So it's really two functions, right? So it's impossible to solve for y and only have a single function. It ends up being two functions. All right, so you end up getting two equations. Now we could take the derivative, so you don't have to write this, but we could take the derivative of each of those. So if I had y equals the square root of 25 minus x squared, we would just do the chain rule. We'd treat it as 25 minus x squared to the 1/2, and then we would do y prime, which would be 1/2 times 25 minus x squared to the negative 1/2 times negative 2x. And we'd end up getting negative x over the square root of 25 minus x squared. And we could do the same thing for y equals negative square root of 25 minus x squared. You can all do all the work for that one, and you would end up getting x over the square root of 25 minus x squared. Okay? So you could take the derivative of those. But there's actually an easier way. So the easier way is to not come up with the two equations and just take the derivative of x squared plus y squared equals 25 as it is. Okay, so this is called implicit differentiation. So for number 1a, it says find dy over dx if you have x squared plus y squared equals 25. So we're going to take the derivative just as it is. Okay, so what we're going to do is we're going to take the derivative, and every time we take the derivative of a y term, we're going to tack on something. Okay, we're going to tack on dy over dx, which means the derivative of y in terms of x values. Okay, but we don't do that for x, because really if I did the derivative of x with respect to x, like think about units. If I had minutes per minutes, did we write anything? No, minutes per minutes is just 1, right? So we don't do a dx over dx. We just do dy over dx. So as I do this, I take the derivative of x squared, which is just what you think it is, 2x. And I take the derivative of y squared, which is going to be what you think it is, 2y. But since it's a y term, we tack on dy over dx. So we're saying we took the derivative of a y term, and we're taking it with respect to x. It's kind of weird, right? All right, what's the derivative of 25? 0, right? Don't write 25. A lot of people will do that. So when I solve for dy over dx, I end up getting negative 2x over the 2y, which gives us negative x over y. So that is the derivative. That's dy over dx. That's y prime, right? We found the derivative in terms of, or we found the derivative of y. Okay, but it's a little bit different. We said the derivative of the square root of 25 minus x squared was this. It doesn't look anything like this. What's different? There's a y still in it, right? Do you guys understand that? So what could we do with the y? Well, we could take our original and we could solve for y, and we could get y is equal to plus or minus the square root of 25 minus x squared, and you could plug it in. So for the first one, we would have negative x over y, which was positive square root of 25 minus x squared, right? That was the derivative of this one. But if I took the derivative of this one, it would be negative x over negative square root of 25 minus x squared, right? And that's why we had just a positive there. Does that make sense? Do you guys get what I'm saying? So that's where why it's just negative x over y. All right, so for implicit differentiation, you can actually leave y as part of your derivative, okay? There are instances where the AP test doesn't, and I'll show you what I mean by that. Maybe for multiple choice, maybe they go ahead and plug in y. But for the most part, the reason we invented implicit differentiation is so we can do this. We can take the derivative without solving for y. So why solve for y in the end, right? All right, so here we go. So the next one says, well, part B says find the equation of the tangent to the circle at the point 4, 3. So if we have x squared plus y squared equals 25, and we're trying to find the tangent line, the equation of the tangent line, well, we know our slope, dy over dx. It was negative x over y, right? So that gives us m is negative 4 over 3. We plug in x and y. So our equation of our tangent line is y minus y1 equals m times x minus x1. So y minus 3 equals negative 4/3 times x minus 4. Oh, let's see. So number 2 says, well, what if we have a more complicated function? What if we have x cubed minus xy plus y squared equals 4, and we want to find the equation of the tangent line at 0, negative 2? Okay. This is definitely a lot harder. We can't solve for y. Okay, again, it's not a function. You can graph it. You'll see that it's not a function. You can graph on Grapher, not really on your calculator very easily. So we need to use our implicit differentiation to find the derivative. Okay, so anytime we take the derivative of the next term, we don't tack on anything on. But anytime we do take the derivative of a y term, we do. Okay, so we're going to start it out. Derivative of x cubed is going to be 3x squared. But then we have the derivative of x times y. So we have to do the product rule. So I'm going to go ahead and do parentheses for that part. So when I do the product rule, I have x times the derivative of y. What's the derivative of y? 1 what? 1 times dy over dx, exactly. Plus the derivative of x is 1, and then y is just y. I don't tack on a dy over dx to the y because I wasn't taking the derivative of y there, right? It was just y, just as it is. All right, then plus the derivative of y squared is going to be 2y dy over dx equals derivative of 4 is 0. Okay, so at this point, you can make things complicated on yourselves, and you can try to solve for dy over dx, or you can realize, oh wait, I'm trying to find the slope at a point anyway. I need to plug in 0, negative 2 at the end anyway, so at this point, you can plug it in. So plug in 0, negative 2 here, because you don't want to go too far. Like, plugging in 0 is always nice. A lot of things will go away. So 0, negative 2, so I get 3 times 0 minus 0 plus 1 times y, so negative 2, plus 2 times negative 2, dy over dx equals 0. So I get 0. I have negative 2, so 2 minus 4 dy over dx equals 0. So I get dy over dx equals, I subtract my 2 over, and I divide by negative 4. So I get 1/2. So that's my slope. So if I want my equation of my tangent line, then it's y minus a y1, so y minus a negative 2 is plus 2, equals m, which was 1/2, times x minus 0. That's my equation of my tangent line. So what a lot of people will do on this problem I ask a lot of these on homework, is they'll try to take the 3x squared minus x dy over dx minus y plus 2y dy over dx equals 0. So they go from this step down to here. And then they try to solve for dy over dx first. So they try to maybe add the x dy over dx over and subtract the 2y dy over dx over. And then you get 3x squared minus y. And then you can factor out. So see how you can pull out the dy over dx, which you will have to do if you don't have a point. You'll have to do something like that. So you pull out a dy over dx, and then you have x minus 2y. And then they divide that x minus 2y over. So you get 3x squared minus y over x minus 2y equals the slope dy over dx. And it works out the same. Like if you plug in 0, negative 2 here, 0, negative 2 gives you 2 on top. 0, negative 2 gives you 4 on bottom. 2 over 4 is still 1/2. Does that make sense? But sometimes these are super complicated to get dy over dx by themselves. So on your AP test, always save time. Always plug in the point if you're given the point. And plug it in right after you take the first step, the first derivative. Okay? All right, so next one. So what if we have x squared y minus xy squared equals -6? So you guys can kind of try along with me. Yeah, Susie?
Well, explain why we add dy over dx.
Yeah, because I don't know the best way to explain it. You'll definitely understand when we do related rates, because we'll be taking the derivative with respect to time. So like everything's going to be a rate with respect to time. So if you had like feet and you were taking it with respect to minutes, then every unit would be like feet per minute, feet per minute, feet per minute. So y, we don't know what it is. Okay, so when you take the derivative of y with respect to x, you have to indicate that you've done that. Like y could be any function. You don't know what it is, so you have to do that. All right, so here we go. So we have 2 times that we're going to do the product rule. Do you guys see it? And the derivative of -6 will be 0. So I'm going to do the product rule twice. So I'm going to have x squared times the derivative of y. So the derivative of y is going to be 1 times dy over dx. Plus the derivative of x squared is 2x. And the derivative, or in y as it is just y. All right, and then I have first times derivative of the second. So derivative of y squared is 2y dy over dx. Plus 1 times y squared. You guys all understand that? So again, we have a certain point. So don't waste time solving for dy over dx when you can just start plugging in numbers. Okay, so we're going to plug in x equals 2 and y equals -1. So I have 2 squared times dy over dx plus 2 times 2 times -1. I'm going to distribute the negative into both. So I'm going to have -2 times 2 times -1 dy over dx, negative, so minus, -1 squared equals 0. So I get 4 dy over dx minus 4 plus 4 dy over dx minus 1 equals 0. So I want to solve for dy over dx. So I'm going to add the 4 over and add the 1 over, so I get 5 on the other side. And when I combine my 4 dy over dx plus another 4 dy over dx, I get 8 dy over dx. So dy over dx ends up being 5/8. So that's the slope at that particular point at 2, -1. So your equation of your tangent line then is y minus a -1, so plus 1, equals 5/8 times x minus 2. So you just finished that. You guys kind of understand what we're doing? So basically taking the derivative, but anytime you take the derivative of a y, you put a dy over dx. All right, so number 3. So number 3 says just find dy over dx, but it doesn't give you a point this time. Okay, so this is when you're going to have to isolate all the dy over dx's and solve. Okay, so 3a. So we have x cubed plus y cubed equals 1. So we don't have a point, so we just want dy over dx, which is the same as y prime. So really, as you're doing these problems, you could write y prime, and a lot of people will, like here and here. If you just had times y prime, that's totally fine. It's just I don't typically write it because a lot of students will miss that y prime. They'll think it's y to the first, or they'll just like lose the prime along the way, and it gets really messy. So I personally think it's better to leave it as the dy over dx. Okay. That's the same thing. All right, so on this one, so I'm going to have 3x squared times, times, it's not like dx over dx, right? So we leave it off, plus 3y squared dy over dx equals the derivative of 1 is 0. A lot of people will leave the 1. They just like get so hung up on like remembering the dy over dx that they forget the simple things. Okay, so I'm going to subtract my 3x squared over. And I divide by 3y squared. So I end up getting -x squared over y squared. That's my slope. So that is the slope for any point along that original curve. Okay, so what I was saying before is your AP test might leave this as your answer. So like if it's a multiple choice, this could be one of the answers, like the y could be in there, or it could be replaced. So if you go back to your original and you try to solve for y, this one you can actually solve for. Y cubed is going to be 1 minus x cubed. And then when I take the cube root of both sides, I get y equals the cube root of 1 minus x cubed. So replacing the y with the cube root of 1 minus x cubed, you might also have the answer negative x squared over 1 minus x cubed. It's like to the 1/3 because it's under a cube root, but then it's squared. So to the 2/3. So you might see that on the multiple choice as well. Does that make sense? So just be looking for that. If you don't see your answer, see if they just plugged y back in. Okay? It's kind of tricky. I personally don't like that because it's like, well, why didn't we just solve for y in the beginning and then just use the chain rule, right? Because that's the answer you would get if you did do the chain rule. But all right. So anyway, so the next one. So if I have sine of y equals x, so this one would be difficult to solve for y originally. Does anybody know how to do that? If I wanted to solve for y? It equals what? If I solved for y originally, it'd be inverse sine of x. Do we know the derivative of inverse sine? Nope. So this is one that we wouldn't know how to take the derivative of in the first place. It's not like sine of x raised to the -1. It's not the same thing. Right, inverse sine, you guys remember? But that's not the same. Okay. So yeah, we don't know how to take the derivative of inverse sine yet. We will learn that, but we don't know at this point. So this is one where we wouldn't really do that. We would have to do the implicit differentiation. So the derivative of sine of y is going to be cosine of y times dy over dx, and the derivative of x is going to be 1. So we're going to have dy over dx equals 1 over cosine of y, which is really the same as secant of y. So if they put the y back in this one, it would be secant of inverse sine of x equals dy over dx. Really gross, right? So we don't typically put things back in. Okay. And then C. So this one we have cosine of 1 plus y equals sine of x plus 5. So if we're taking the derivative of cosine of something, it's going to be a negative sine of something times the derivative of the something, right? So the derivative of the inside, what's the derivative of 1 plus y? Yeah, it's just the dy over dx, 1 dy over dx, right? It's a y term. And the derivative of sine of x, cosine of x, derivative of 5, 0. So dy over dx then would be cosine of x divided by negative sine of 1 plus y. So I'm going to write sine of 1 plus y on the bottom, and then I'm going to put a negative on top. So I have negative cosine of x all over sine of 1 plus y. 1 plus y is a little weird. All right, and again, that would be a hard one to solve for y, because you'd have to like do inverse cosine. It would be very, very messy to have the y by itself. So we'll leave it like that. All right, so second derivatives. Fun, fun, fun. You ready for it? So number 4 says find y double prime if you have x to the 4th plus y to the 4th equals 16. Okay, so just like before, if we were finding the second derivative, we're just going to do it twice, right? So first time. So I get 4x cubed plus 4y cubed times dy over dx equals 0. And we subtract the 4x cubed over. And we divide by 4y cubed. So we end up getting negative x cubed over y cubed. So that's the first derivative. That's y prime. So what do you think we do? Do it again. So if we're going to do it again, really the way we'd write the second derivative is d2y over dx squared. But I know most of you guys probably don't like that notation. You're like, what? It's your faces. So you can also just write y double prime, right? Same thing. Okay, so when I do low d high minus high d low, I have to do the dy over dx for the d low part, all over the square of what's below, that. So y cubed times negative 3x squared minus negative x cubed times 3y squared dy over dx, all over y cubed squared. And we simplify a bit. So we have negative 3x squared y cubed, and then we have plus 3x cubed y squared dy over dx, all over y to the 6th. Okay? But we do not leave dy over dx in there. Okay, we replace it with something. What should we replace dy over dx with? This. Yep, you see it? Negative x cubed over y cubed. That's what it's equal to. So we replace. So when we do that, we have negative 3x squared y cubed, and then we have plus 3x cubed y squared times negative x cubed over y cubed, all over y to the 6th. And it's kind of messy. We don't leave things as fractions within fractions, so we try to simplify. So we can at least see that the y squared and the y cubed reduce out to just y on the bottom. So we have negative 3x squared y cubed minus 3x to the 6th over y, all over y to the 6th. And we still can't leave it like that. So any ideas? How do I get rid of that y that's on the denominator at the top? Yeah? What do you think, Elena? You could. Like, you could do y to the negative 1, but that's still really just a fraction within a fraction. Yeah, what do you think, Emma? Yeah, we're going to multiply it on the top and the bottom. So we're going to multiply by y over y. Do you guys see it? Because now, on the top, we're going to have negative 3x squared y to the 4th, and then minus 3x to the 6th, and the y's go away there, all over y to the 7th. And that's the answer that we're looking for. So that is the second derivative. That's y double prime. So I never liked those when I was in school. I was always like, oh, I gotta like plug this in still. Especially if it's really messy, it's gross. All right, and then the very last question is a true AP question from before. So it says, find the points at which the graph of 4x squared plus y squared minus 8x plus 4y plus 4 equals 0 has a vertical or a horizontal tangent line. So find the points. So you might want to underline the word points. That's important. It's not saying the location. It's not saying at x equals whatever. It's not saying the x value. It's saying the points. So find the points where the tangent is horizontal or vertical. Okay. So first, in order to find where I have a horizontal tangent line, I want to find the slope, and then I want to set it equal to what? 0. What if I want I just told you, a vertical tangent, right? That's when you find it undefined. So how do you find an undefined slope? How do you get anything, right, if you have a denominator equal to 0, then that's undefined. Okay, so let's go ahead and find dy over dx. We're going to do this implicitly. Do you guys know what shape this is? Just looking at it. Are you good at your conic sections? No one? Crickets? It's an ellipse because it's an x squared plus a y squared, but they're not the same number out front. So we have some kind of ellipse, okay? So you could actually solve for y. It would be a little bit complicated. You have to complete the square. I won't put you through that. We'll just go ahead and do our dy over dx, our implicit differentiation. So we're going to do 8x plus 2y dy over dx minus 8 plus 4 dy over dx plus 0 equals 0. Okay, and I solve for dy over dx, meaning I get my 8 and my 8x over on the other side. So I add 8, I subtract 8x, and then I look for the two things that have dy over dx, so I can pull the dy over dx out of both of them. So I have 2y plus 4. So I end up getting 8 minus 8x all over 2y plus 4 equals dy over dx. So does that simplify at all? Yeah, they're all even numbers. So you could divide by 2 on the top and divide by 2 on the bottom. Or multiply by 1/2 on top and bottom. So you get 4 minus 4x all over y plus 2. Okay, so let's start with the tangent line as horizontal. In order to have a horizontal tangent, we want our slope to equal 0. So that means we want 4 minus 4x to equal 0. We want the numerator equal to 0. So we end up having x equals 1. Okay, but I said find the points. This is not a point. This is a location. So if I just said find the locations of the x values, right, you would be good, but we wanted the point. So how do I find that y coordinate that goes with it? How have we done that in the past? Yeah, just go back to the original, right? We're going to go back to the original. We're going to plug in. So plug into original to find the y. Only it's kind of gross, because when we're plugging into the original, we're going to have 4 plus y squared minus 8 plus 4y plus 4 equals 0. So we have y squared and y. But at least the 4 minus 8 plus 4 goes away. So we have y squared plus 4y equals 0. So y times y plus 4 equals 0. So we end up getting y equals 0 and y equals negative 4. So what are the points where the horizontal line is where the tangent line is horizontal? 1, 0, and 1, negative 4. There's 2 points where it's horizontal. Right? You guys see we found the y values that went with x equals 1. All right, so now what if we want vertical? So for vertical, we want our slope to be undefined. So the only way for our slope to be undefined when we have that fraction, 4 minus 4x over y plus 2, to be undefined is if y plus 2 is equal to 0. We set our denominator equal to 0, so we get y equals negative 2. But again, we don't have a point, we just have a y value. So now we go back in, and we plug in y. So we have 4x squared plus 4 minus 8x minus 8 plus 4 equals 0. So I plugged in y equals negative 2. And luckily, a little bit goes away. So like the 4 plus 4 minus 8 becomes 0. So we have 4x squared plus 8x equals 0. No, wait, minus 8x equals 0. Very close. So we can pull out a 4x, and we have x minus 2. So we get x equals 0 and x equals 2. So we originally had a y value, y equals negative 2, so we want to make sure we put that in as a y value. So our points where it's vertical are going to be 0, negative 2, and 2, negative 2. And those are the other ones. Okay, that was a true AP question. Lots of steps, right? Takes a little bit. All right, any questions on implicit differentiation? Do you guys understand the concept? Yeah, it's not too bad. It's just everybody always does that first homework and they forget their dy over dx. You just get in a hurry and you forget all about it. So be very careful.